You know, when you're diving into the world of AI, it feels like there's a whole new language to learn, right? Well, getting these key terms straight isn't just about sounding smart. It's absolutely crucial for understanding the tech that's changing everything. So today, we're going to unpack 5 pairs of the most common and honestly most confusing terms out there. By the end of this, you'll be able to navigate these conversations like a pro. And just so you know where we're getting our facts, everything we're talking about today comes straight from Chapter 6 of a document called The Ethical AI and AI Security Glossary by Virtualization Options LLC. It's a really solid resource, so we know we're working with clear, standard definitions here.
So let me ask you, if someone put you on the spot right now, could you explain the difference between, say, ethical AI and responsible AI? Or training data and test data? Don't worry if you hesitate because it's genuinely tricky. They sound so similar, but getting them mixed up can create some pretty big problems when we're trying to build AI the right way. All right, here's the plan. We're going to tackle 5 key comparisons. We've got what versus why, accidents versus attacks, then principles versus practice, simple versus complex errors, and we'll wrap up with a really good one, study hall versus the final exam. Let's get into it.
First up, what versus why? This is all about transparency versus explainability. And really, it boils down to a simple idea, knowing what an AI system is versus understanding why it makes the decisions it does.
So transparency is kind of like the About Us page for an AI. It's the big picture stuff, right? It tells you, hey, an AI is being used here, this is what it's for, and here's the kind of data it eats. It's general info. But explainability, that's totally different. It gets super specific. It's about zooming in on one single decision and asking, why did it do that?
Okay, let's make this real. Imagine a bank. Transparency is the sign on the wall that says, we use an AI for loan applications. Okay, good to know. But what happens when your loan gets rejected? That's where you need explainability. You need the system to tell you exactly why you were denied. Maybe it was your debt-to-income ratio. And this is why it matters so much. Transparency tells you the game is being played, but explainability gives you the rule book, so you can actually challenge a bad call.
All right, moving on to our second pair, we're looking at accidents versus attacks. This is the core of the difference between AI safety and AI security. So AI safety is all about protecting us from the AI itself. We're trying to prevent it from causing harm by accident, because of bugs or flaws or just weird unintended behavior. The threat is coming from inside the house, so to speak. Now, AI security, that's about building walls and locking the doors. It's about defending the system from bad actors who are deliberately trying to mess with it. The threat is external. And this car analogy just nails it. Think about it. If your car's brakes fail because of a factory defect, that is a safety issue. But if they fail because someone cut the brake lines, well, that's a whole different problem. That's a security breach. And here's the bottom line. You have to have both. A system can be as secure as Fort Knox, but if it's full of bugs, it's still a danger. And on the flip side, a perfectly safe system is worthless if a hacker can just walk in and take over. Okay, number 3. This one's a big one. Principles versus practice, or as it's known in the field, ethical AI versus responsible AI. So, ethical AI, that's the why. It's the part where we step back and ask the huge questions, like, should we even be building this in the first place? What are the moral implications? It's the philosophy. Then you have responsible AI. That's the how. It's the nuts and bolts. It takes those big ethical ideas and turns them into a practical game plan, asking, okay, so we're building it. How do we make sure we do it right, with accountability and proper governance? I love this analogy. Think of ethical AI as your moral compass. It just points you in the right direction, towards good. But a compass alone doesn't get you there, right? You need a map. That's responsible AI. It's the detailed map and the checklist that guides the actual journey. And you absolutely need both, because ethics without action is just a nice conversation. And action without ethics, well, that's just building stuff blindly, and that can be really dangerous. Okay, we're going to get a little more technical for a minute, but I promise it's worth it. We need to talk about bias versus variance. And right off the bat, I have to be super clear. When we say bias here, we're talking about a statistical thing, not the social or ethical bias that we talk about a lot. Totally different concept. So in machine learning, there is this constant balancing act called the bias-variance trade-off. Imagine a seesaw. On one side is bias, on the other is variance. There are 2 different kinds of errors a model can make. And a tricky part is, when you push one side down, the other side almost always goes up. The whole game for developers is finding that sweet spot, that perfect balance, so the model actually works well on new data it's never seen before. So let's look at the two extremes. A model with high bias is way too simple for the job. We call this underfitting. It's like trying to draw a detailed portrait with a big, blunt crayon. It just misses all the important details. It does poorly on everything. On the other hand, a model with high variance is the total opposite. It's too complex. This is called overfitting. This is the student who doesn't learn the concepts, they just memorize the textbook word for word. They'll ace any question they've seen before, but throw them a new problem on the final exam, they're lost. Both models fail, just for different reasons. And that whole student analogy is the perfect lead-in to our final pair, which might be the most fundamental concept of all, study hall versus the final exam. We're talking about training data versus test data. Okay, this is super important, but actually really simple. The training data is basically the model's entire curriculum. It's all the textbooks, the practice problems, the study guides, everything it's allowed to look at to learn patterns. The test data, though, that's the final exam. It's kept completely separate, like a secret. The model never gets to see it while it's studying. Why? Because that's the only real way to find out if it actually learned anything, or if it just memorized the answers from the textbook. And I can't stress this enough. Keeping them separate is the cardinal rule. If you mess this up, if you let the model peek at the final exam questions while it's studying, which we call data leakage, you're just cheating. Sure, the model will get a perfect score, but it hasn't actually learned anything. It just memorized the answers. That model might look like a genius in the lab, but the second you put it out in the real world, it's going to fall flat on its face. All right, let's do a super quick rundown of everything we covered. Transparency versus explainability, that's knowing what versus understanding why. Safety versus security, that's preventing accidents versus preventing attacks. Ethical AI versus responsible AI, that's the principles versus the practice. Bias versus variance, that's underfitting versus overfitting. And finally, training data versus test data, that's the textbook versus the exam. Simple as that. Look, getting these terms right isn't just about winning an argument or sounding smart. It's the first step. It's foundational. When we all share the same vocabulary, we can start having the real conversations. So the question I want to leave you with is this. Now that we're on the same page, how do we use this clarity to ask tougher questions, to demand more accountability, and to actually build an AI future that works for everyone? That's the real challenge ahead.